I want to look at quadratics in a different way. So what I've done is I've graphed a few quadratic functions, and while we'll discuss domain and range possibly and increasing and decreasing, I really want to focus on the vertex and the axis of symmetry. So let's look at this equation here. This equation is y equals x squared minus 8x plus 13. The red graph you see here is the parabola. Now, there are a few things that I want you to notice. Notice here that my leading coefficient is 1. So when that happens, we're going to follow this rule that we have sort of been discussing about graphing your parent function x squared. So keep that in mind as we go through. So I notice that my leading coefficient is positive, so my parabola is going to open up. Let's look at the vertex. The vertex is located at 4, -3. The axis of symmetry, remember, is a vertical line on which the parabola folds onto itself. So the axis of symmetry is x equals 4. And since this opens up, we have a minimum value, a lowest known value of -3. And I put these in color because I want you to see what the vertex does. The vertex doesn't just tell you about one point on the graph. It gives you the axis of symmetry, and it gives you the minimum value or the maximum value. And see how a equals 1 here? Think about what we've discussed in the past. When I start at my vertex, I go to the right 1 and up 1. I go back to my vertex. When I move right 2, I go up 2 squared, which is 4. If I were to travel to the right 3, then I would actually have to go up 5, 6, 7, 8 to like 9. So notice the rules here. 1 squared equals 1. A move of 2 takes you 2 squared, which is 4. A horizontal move of 3 takes you vertically 3 squared, which is 9. A horizontal move of 4 takes you up 4 squared, which is 16. And remember, I love BOGOs, so when I know this point is 1 unit to the right of the axis, I know I get this point for free. This point is 2 units to the right of the axis, so I get this point 2 units to the left for free. So please take a minute and look this over and make sure that it makes sense to you. All right, you ready to go to the next one? Let's go. Now I have y equals -x squared minus 8x minus 13. So here's the graph, and doggone it if this one isn't opening down. And the reason it's opening down is because the leading coefficient is negative. My vertex is -4, 3, which is told to me right here. My axis of symmetry, therefore, I should use the highlighter, is going to be x equals 4, which is here. My maximum value, it's a maximum value, that's my largest known point. My maximum value is 3, and that is actually the y coordinate. Okay, so again, the x coordinate of a vertex tells you the axis of symmetry. The y coordinate of the vertex tells you the max or the min. And please notice that we have 1 squared or -1 squared here. So we're going to follow the same pattern. A horizontal move of 1 moves us vertically 1 squared, which equals 1. A horizontal move of 2 moves us 2 squared vertically. A horizontal move of 3 is 3 squared vertically. A horizontal move of 4 is a vertical move of 4 squared. And you can see that here. Horizontal 1, vertical 1. Horizontal 2, vertical 4. A horizontal of 3 would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? All right. Next one. Take a minute, look it over. Again, my leading coefficient is negative, So this parabola opens down. Once I know it opens down, I know that I'm going to have a max, okay? And that happens at the vertex. My vertex is 1, 2. So here that is. My axis of symmetry is x equals 1 because the x coordinate of my vertex is 1. My maximum value is 2 because the y coordinate of my vertex is 2. And again, we're going to follow the same pattern. Horizontal move of 1, vertical 1 squared. Horizontal move of 2, vertical 2 squared, which is 4. So again, I'm following the same patterns. So take a minute. All right. Oi, this next one, 3 squared. Y equals 3x squared. My bad. So I look at the parabola. I see the vertex is at 0, 0. My axis of symmetry, therefore, is x equals 0. Since this opens up, it has a minimum value of 0. Again, let's do this. X coordinate tells me the axis. Y coordinate tells me the max or the min. Now, this one's a little different because if you look up here, A equals 3 in this problem. A, sorry about that, guys. I'm drawing this with my mouse. A equals 3. So look down here. Instead of moving 1 squared, we take a factor of 3 times 1 squared. So we get 3. So from the vertex, a horizontal move of 1 gives us a vertical move of 3 times 1 squared. And now let's look at what happens at 2. 2 squared equals 4, but we have the 3 in front. That's the amount of our vertical stretch, our dilation. 3 times 4 is 12. So when I move to the horizontal 2 units, square that to get 4, but we have to do that 1, 2, 3 times, and that puts us at that point. And y'all, I can make tables all day with this, but it's easier just to reason through what a horizontal displacement or how a horizontal displacement affects a vertical displacement. That's really all that I'm doing here. All right, so take a minute and look at this one. All right, now before I talk, look this over. So this one, the leading coefficient is A equals negative 1/2. So we know it opens down. My vertex is still 0, 0. And again, the x coordinate of the vertex gives me my axis, x equals 0. The y coordinate gives me my maximum value. And again, I know it's a maximum value because that's the largest known quantity. All right? So if A is 1/2, instead of going right 1, down 1, we're going to go right 1, down half that much. See, 0.5. Instead of going right 2, down 4, we're going to take half of 4, which is 2. The next one would go, instead of right 3, down 9, we take half of 9, which is 4.5. And you get the idea. Now, this one is not in standard form. This is called vertex form, which we will discuss shortly. But again, I still have a value of A here. It is positive, so my parabola opens up. That's still the same. One thing we're going to talk about is the vertex is right here. It's a positive 4, and it's a negative 2. And still, my x coordinate of my vertex is my axis of symmetry. The y coordinate of my vertex is my minimum value. And it's a minimum value here because that's the smallest known value. And because a is 1/2, we're scaling our squares again. To the right 1, up 1/2. To the right 2, up 1/2 of 4, which is 2. To the right 3, up 4.5. Oh, that puts me right there. Oh, I even had another point. I didn't even know it. There it is. We had to move up 4.5. Oh, I kind of like that. Okay. Let's look at one more. We're standard form again, but notice that I have a leading coefficient of 2. The leading coefficient of 2 is positive, so this parabola opens up. I'm going to play my vertex game again. The x-coordinate of my vertex is my axis of symmetry. The y-coordinate of my vertex is my minimum value. And again, you can see the axis of symmetry here. My vertex is here. Now notice this one. Instead of going to the right 1, up 1, we're going to go to the right 1, up 2, because we double our vertical displacement. Instead of moving to the right 2, up 4, we're going to move to the right 2, up 8 because of my vertical displacement. So you see that happening there and there. If we were to move over 3 units, instead of moving up 9, we would have to move up 2 times 9, which is 18. Okay? So whatever number is your leading coefficient, that's the number by which you multiply to get your vertical distance. Okay? So please go back and look at these as you need to so that you can see where I get the axis of symmetry from the vertex, where I get the maximum or the minimum value from the vertex. You can see the leading coefficient. It tells you whether the parabola opens up or down. And just remember, anytime the parabola opens up, you're going to have a min. So let's kind of put that in here. If you open up, there's going to be a minimum value. And if the parabola opens down, there will be a maximum value. Okay. Last but not least, we're going to start talking about the vertex form of a quadratic. So I would like for you to be able to look at a function and pick out its vertex right away. So when I look at this first one, I know that I take the opposite of what's here and I bring it down. Okay? Because remember, it was, oh goodness, I should have typed this. It was x minus h squared plus k. So you take the opposite of what's there. What's the opposite of plus 5? Minus 5. And then you bring over the 8, okay? And then the axis of symmetry, remember, matches the x-coordinate. Let's look at this next one. So the x here is x minus 4. What would zero that out? A positive 4. And then we carry over the plus 7. And then the axis of symmetry is x equals 4. Here, the vertex is negative 2, positive 6. And the axis of symmetry is x equals negative 2. For example 4, the axis, we take the opposite of what's here, so it'll be a positive 2 and then a negative 6. For this one, we take the opposite of what's in here, it'll be a positive 2, but we paste a positive 6. Here, the opposite of 2 is negative 2, and we paste a negative 6. And notice how the axes of symmetry fall in line there. So that's what I want you to notice here. You always take the opposite of what's inside the parentheses. Because what I'm really doing, if I were to look at this problem right here, I'm really saying, okay, well, x plus 2 equals 0. What would you do to solve that? Well, you would subtract 2 from both sides, wouldn't you? Then your final answer would be x equals -2. And so if you look here, x equals -2. All right? So please take a minute, look at how the sign changes for the x, but the y coordinate stays the same. And then the axis of symmetry comes straight from the x coordinate of the vertex. So I hope this kind of helped you a little bit to figure out how the vertex affects the max and the axis of symmetry, and how the leading coefficient affects whether it opens up or down.